Rajesh is actually a PhD from Georgia Tech, and his partner is also a PhD from Georgia Tech, and the two of them have co-founded a company called EdgeTensor. This is fascinating technology. It's artificial intelligence at the edge. Welcome, Rajesh, please.
Thank you. Very exciting to be in AI now. So you all know about the Uber accident that happened. So this was the video. So I just pause there. So basically what was happening was, this is an autonomous fleet from Uber that was driving down, and it I think ran over a lady and she died. So basically what we're doing here is we are able to provide the alert almost 20 seconds before the crash happened. So if you look at the entire video, so yeah, just to go over what we're trying to do here. So this is a AI engine running on a commodity hardware. So this sits inside a vehicle, and there's a camera looking onto the driver, and then it tries to do a couple of things on the face here. So what we have built is a low cost AI engine that does gaze estimation, head pose estimation. So what I mean by that is where the person is looking, where the eyes are looking, and head pose is basically orientation of the head in the 3D space. So both of those help us distinguish distraction driving. So it can be anything from the person is fatigued, or he's drowsing, or he's busy with his cell phone, or doing something with his kids, any of those. So we can actually classify each of these events and alert the driver in the form of an audible alert, or we can actually vibrate the steering or the seat or whatever the automotive guys or the fleet guys want to do. So this is basically a teaser video here. And I'll just continue the presentation. So our product is called Andria, so which means in Indian Sanskrit language, Andria means the five senses, which is the eyes, ears, and whatever you have in your face. So just a little bit about the company. So my name is Rajesh, and Smriti is my co-founder. So we both went to Georgia Tech at different times, and we got together and started this company. So what are we looking at here? So basically the focus is AI on the edge, and why do we need to do edge computing? So you're all familiar with cloud computing, which is basically sending data. A lot of big companies, Amazon, Google, they all do AI processing on the cloud. So it's intensive, because AI is data intensive, compute intensive. So you need really GPU-based devices to handle such compute capability and data bandwidth. But our mission here is to not use any GPU or any high-end computing, but bring the same capability of AI to commodity hardware. So what we have done here is, of course, the issues with cloud computing are, the speed, latency, you're at the mercy of the Wi-Fi all the time, and then this reliability and safety, because you are putting your data on somebody else's server. And also, the added cost of, we were talking to a body camera company that they were telling that the Houston PD, I think, in a month, they get about 30 petabytes of data, and they have no way how to handle it and where to store it, how to process it and stuff like that. And there is a solution where what we are doing here could really help, because all the processing that we do is on the edge, and it's all low compute edge processing. So our solution is, we have come up with this with an SDK called Andria, which is accurate, efficient, and cost-effective edge-based solution that works on any camera and any hardware. So we don't have any limitation as to okay, we need a specific hardware or a specific camera. So we have done a bottoms-up approach. So what I mean by that is we own every line of code. So if you look at in the AI space today, most of the startups are companies that work on AI. They are either dependent on platforms from big companies like Google, Facebook, or Microsoft. So what we did is when we were in stealth mode, we took up the time to design the entire IP in-house. So we have access to every line of code. So that gives us a lot of leverage to port it on low power hardware. So to give an example of what that today, if I do a face tracking using TensorFlow, which is actually a platform provided by Google, it can run at max 8 to 10 FPS on say Snapdragon 835, which is on your Galaxy S8. And the same algorithm using our models or our network can run at 40 FPS. That's the difference in performance that we get. So what this lets us is at the same compute power, we can provide more features to the end customer. So what that means is, if Google TensorFlow can just do face tracking or face detection, we could do we can do gaze, we can do head pose, we can do emotions, all of the above on the same phone and running in real time. So that gives our customers more value for money, and basically our value proposition is our equipment is $150, and we do a $25 per month subscription. So we provide a cloud backend where you get only analytics that are event driven. So I was talking about this data problem that a lot of cameras are recording data continuously, but what mostly happens is it's a static camera looking at like a room like this, and most of the time there's no activity going on. So it's in our 24-hour time period, it's hardly probably 1 or 2 hours of activity, and then but the video constantly keeps getting uploaded. So here we can reduce it considerably based on event based, and we can even go further, and our AI lets you to configure events on the dashboard. So we can say I want to look for only a German Shepherd, for example, and I give me German Shepherd when it comes in this box here. I can draw a box and tell the camera to just look for the dog when it comes to that square. So things like that. So AI opens up a lot of a huge market where we can now go into and do query based AI. So again, affordable AI on the edge is we are always on, and it's real-time AI. So it works with any camera, and we have edge compute, real-time edge compute IP, which is basically a low-cost device. So an example would be a smartphone is a very classic example of a edge compute device because it has a camera and all the sensors that you need, and that is exactly what we use in the box. So we have a Snapdragon 625, which is a 4-year-old processor that came out in 2014. So we are able to run our AI solution on that processor using just 50% of the resources. And most of the AI today, can hardly run. This is the next generation of Snapdragon, which is like 2018, and most of the AI solution can barely run even on this phone today. So that's where our edge is. We are giving you more value for money. And as already we talked about this video, so here this was so the product that we have in the markets are one is in the driver monitoring space or the mobility space. So here the idea is to do distracted driver monitoring, and what enables that is all this technology that we provide. So face tracking, and we do tracking of 48 landmarks, and we do head pose tracking and location, gaze direction and location, and then we do age, gender, face recognition, and identification and emotion recognition, and we are also working on body pose tracking, vehicle detection, and license plate recognition. So basically, all the face-based IPs can actually run parallel on a phone today. So I can show you a demo, a real-time demo. between, so you get an idea for what I'm talking about. So why do you need to choose our solution? We are AI based, so what I mean by that is every line of code is proprietary, so we can actually work with the end customers to provide value for the money, and that's why even customers are very happy working with us. The example is a lot of this solution that I see today. The gap is that the camera that comes out, of course they are like in thousands of dollars, and then it will only work with their equipment, their dashboard and stuff like that. I mean, there's a lot of stickiness built into it. So at the end of the day, you'll end up spending quite a lot on changing the infrastructure, and plus the return on investment for you to break even takes like a lot of time. With our solution, we don't have to change anything. We work with our existing hardware because we have designed the AI system so efficiently that it can go into any hardware. If you looked on the video that I was showing, that was running on a GPU, low-end GPU, and it was doing roughly about 1000 FPS. So basically, what I'm trying to say here is our solution, since it works on the lowest performing hardware, we are able to, without changing any infrastructure or and camera also, we are able to provide the same AI solution that other companies provide on very expensive devices. And then it's accurate. Of course, we are benchmarked with all the state-of-the-art solutions in the market and all the academic papers. Of course, I mean, when we bring a product into the market, we need to do our due diligence, and it's efficient. And then it's also cost effective. So compared to the market today, our solution is literally 4 to 5x cheaper than what the other competitors provide. So our advantage is basically, I'll just quickly go through this. It's affordable, expandable in the sense we provide cloud backend with all the analytics, and it's very easy to integrate. We have an app that I can do a screencast right now, and then of course it's industry agnostic. It can solve a lot of problems in different verticals. So we are working with, as I said, in the mobility space. If you think about fleet management, so I know this Omnitrax. I think they do a lot of sensor-based fleet management, basically letting know the driver or the fleet managers how the drivers are doing, stuff like that. So here they are all based on passive sensors. So what we are doing here is visual analytics based on active camera and to provide what's happening in the cabin and stuff like that. So you may argue that okay, things are going into more autonomous in the autonomous direction, and there the safety becomes a big critical issue. So companies are talking to us mainly in the safety, from the space safety perspective. So in level 3 autonomy, the automobile people, they want to assess if the driver can take over the vehicle from the autopilot to the manual mode, whether he is capable of doing it. In level 4 and level 5, they want, so today what is available in the market, all the sensors are looking outwards from the car, and what our solution does, it looks inside the vehicle. So that gives an added advantage, and there's a lot of user experience based applications that are coming up in the autonomous space. So that's one of the biggest areas that we are also focusing on. And of course, there are in the driver monitoring space, there is fleet market. There is insurance companies which are looking into usage-based insurance, which is basically you pay as you drive, and they are very much interested in how the driver is, handling the vehicle and all those things. And there is, of course, app-based rideshare like Uber and Lyft, who are also, using apps to do. Basically, they did all the, their functionality today is on the phones. So I'll just show you a quick demo here. So this is my phone screen here. So this is an app running on the phone, so you can look at it. So this is my this is our AI engine running on the phone. So you can see, like, I give gaze, and it's pretty smooth. I can do, like, I come back. And this is roughly using like 40% of the resources on this phone actually. So just to give you the market here, so the mobility space literally about 12 billion market. So there are a lot of applications that we are looking into. So we are in the process of developing a team driver monitoring apps for parents. And then there is fleet, of course school buses, driving schools, training. So these are all used by for like when you want to get a driver's license for a fleet. The schools can use these kind of technologies to help the driver. Of course, then there are taxis, charter and rental vehicles. I mean, of course, we are looking into as short-term, mid-term, and long-term strategy here. So, usage-based insurance, app-based ride share, and autonomous fleet safety. And long-term is, of course, working with the automotive guys. So, there's already mandate. Europe has already made it mandatory to have this functionality a standard feature by 2020, and a lot of other countries are already looking into having this as a standard feature in the next generation of the vehicles that will come out. And we have repurposed the same SDK into the retail market. So where we do customer demographics. So what I mean by that is a retailer today is interested in knowing who their customers are, what they do in their store, and they want to identify repeat customers. They want to tie a POS transaction to a face. Of course, this is all privacy preserving, and we don't gather any face data or whatsoever. It's all done through deep learning features, and only the features are stored on the cloud. And if you need to do a recognition, we just match some numbers, and then we provide an ID. So for us, a customer is just an ID. There's no names or nothing being stored on the cloud. So that market is also about retailers are going into more like Amazon Go like experiences, and things are becoming, brick and mortar stores are becoming smaller in size, and they want to provide real value to the end customer. So customer analytics, digital marketing, digital signage is the next big thing in retail. And we have a hardware that we have bought, we are working on, which is an integrated screen that has our AI software built in with an integrated camera. It just looks like your laptop screen and in the camera, and then it's just a screen. So you can actually take that and put it wherever you want, and then it will start sending data to the cloud, event-based data. You can configure the dashboard how you want. So basically what the dashboard provides today is it provides how many people came into your store, what was their age, what was their gender, and we can also trigger content that's running on the signage based on who is looking at the content. So if it's a male 30 years old, we can switch content, and if it's a female, things like that. And then so they're also interested in looking at dwell time, which is basically how long the customer was in the store, and attention and all those things. So we provide all those information on the dashboard. So a business model basically is, as I told you, we are in retail signage monitoring, driver monitoring, and of course security system where face recognition, emotions, and tracking people. All those things are very important. So we do three types of engagements. One is the value add. So suppose somebody already has a dashboard, they can use our visual analytics to enhance their dashboard and provide more value for the customers. Of course, IP licensing is the next one, and then we do mobile and camera-based subscription. And also the other thing is we have access to the data that with all the customers that we work with. So that gives us added leverage to improve our analytics on the fly. So we have our deep learning models are capable of learning on the fly, and we can train and retrain very quickly and do an over-the-air update today, so that people or the customers can get added benefits, and then we can keep monetizing by providing superior features to the customers. And this is an example of the driver monitoring system. So we have our solution, the camera placed inside the car, and it's looking at the driver. and that's the camera field of view, and it's detecting driver fatigue, drowsiness, and inattention. And our competition today in the AI space, basically we have a bunch of companies. I think something got messed up here. But yeah, so the main companies that we are that we are against are Seeing Machines, which is one of the companies from Australia. It's been around for almost 10 years now. And Nauto is just this new company that were funded by Toyota AI Ventures early this year, and iSight is another company from Israel. So all these companies, I think there's something missing here, but we have this affordable versus expensive. So both of these Nauto and Seeing Machines today, they are literally their solution works on GPU and FPGA. So they are in the $1,000 range. And also their monthly cost is much more expensive. So if you think about a consumer level car, like you're buying a $15,000 to $20,000 car, and you can't have $1,000 worth of feature that you're paying just for doing driver monitoring. So if it has to come to the mass market, it has to be below $100. So that's where we are providing value to the automotive people. So our solution can be easily, they can do it for in that cost range. And of course, with the accuracy, and still maintain the same accuracy and speed at what these guys are running on GPU today. And in the analytics market, there are in the retail space, there are a bunch of other guys. So some of them are cloud-based solutions, but our solution completely runs on the edge, so you don't have any cloud. So the cloud cost for the customer is very, very minimal. So because we just send few bytes of information, or the customer can choose to send images, videos, it's up to them. So we provide all those capabilities for the customer. And this is basically our driver monitoring market product description. So we have a mobile version and a camera version. So the difference is that, of course, in the mobile version, because it's working from the camera that's on your phone, you cannot do monitoring in the night. So we need an IR camera. So if you buy the solution, the camera-based solution, we do provide IR cameras that works 24/7. And the compute device, of course, in the mobile, the app just runs on your phone, and we don't provide external cameras. So the rest of the things, everything is provided as a package here. And this is the customer analytics market. So the difference here, as I was mentioning, is we provide count, dwell time, estimated age and gender, mood of the viewer, and stuff like that. And we are also in the surveillance market, where we do vehicle detection, visitor tracking, vehicle counting, and all sorts of things. So this is the accuracy of our solution. So I'll just play a video here to go over this. So you can see here it works at extreme phase poses. And partial phases. So most of the solution out there today, they need to have the complete face visible to the camera, because most of them are using some model-based approaches. So here, we don't use any of those techniques. It's all proprietary IP, and that's why we are able to provide, really high accuracy. Even because a lot of countries people do use, only eyes are visible, they cover half of their face. Especially it was a problem in Japan, I think, where people use masks to cover their mouth. And this is showing with the lighting variations. So if the sunlight is shining brightly on your face, things like that. So, and it can also works with face accessories. So you can wear goggles or cap or. And we do have some comparisons with the companies I was just mentioning here. So this is the comparison with a company, Nauto. So let me just start. I just wanted to see that. So here you can see the difference. So the solution from Nauto, when the person actually dips down, they have no features on the face whatsoever, but they still provide the label. It's distracted. I don't know how they do that. It's there. This is the video that I grabbed from their website, and we ran our solution. So you can see our solution still is able to track the face and give all the features. And also, if you notice, in their video, they provide about 5 points on the face. Whenever the person is, you see the 5 points sticking on the end of the eyes and bottom of the face. So there are some dots that's visible. So they provide about 5 like edges of the eyes and nose tip and edges of the mouth and probably one face on the one dot on the chin. So we are able to do like about 50 points tracking on the face compared to I think probably 10 or 12 that they are doing. So because each of these points are, this is process intensive, so every point that you add onto the face for tracking is computation for you. But of course then you end up getting much richer features. And this solution runs on a GPU, so their entire system hardware and the camera integrated costs about $1,000 in the market, and our solution just runs on a phone. So that's the difference. And this is another comparison of our app with the company called Effectiva. So this is the same phone that I am using. Of course, ours is in black and white, but you can see the lag in the other software. So I am already way ahead in my when I'm rotating, and this is still processing some frames that are like really in the past. So for why I wanted to bring this up is even today Tesla doesn't have driver monitoring because the accuracy is 99.99% for these kind of solutions. So you can't mess up these. I mean, you can't even have 2-frame lag, and you can't get an alert after the crash has happened. So you have to be really predictive, not reactive. So so these are some of the security-based applications that we are doing. So all these solutions today, they can detect objects in the scene, and all these are running and on low power devices. And this is actually the customer deployment that we were doing. So this person wanted to know only when something is moving, he wanted to get an alert. So we were able to solve his problem. I mean, this is the accuracies we are looking at today. So even it even detected the person who was driving the van actually. So if the AI capabilities today are like if human can actually tell looking at the scene, what exists in the scene, an AI system can also do that today. So that's the level of accuracy we're looking at. Like for example, there was a person. It's very difficult for somebody to look at and say it, but the camera is actually picking up and telling that there is actually a person. And then issues like all these old school based approaches where most of the video intelligence software today, they rely on motion. So if you give this actual scene with footage, there's all these grasses are moving, and then there is this oil rig that's going up and down. So all the motion based systems will just keep firing alerts. And the problem with this customer was he used to get like 200 alerts a day, but out of that, like 180 alerts were just false alarms. So if you think about a security guard who is looking at like 10 screens and he wants to be detecting this in real time, of course, if out of 200, 180 are false alarms, even if actual event happens, he'll just miss it because fatigue would have set in and he would just miss the whole thing. So that's where our solution is. So this is actually the output of our solution, where we are not detecting anything because we have suppressed our system doesn't even use motion to do any detection. So it is all object based. We have an in-house object detector that we have built using AI, deep learning. So that's eliminated 100% of the false alarms, and we can actually go and, as I was telling you, we can actually do particular object in a given area. So if I want to detect a dog in a particular area of the scene, I can do that today. And of course, works with IR and all those things. So this is a night video. So the car coming back. So all this. And this is the last video, basically to give you more enhanced features. So this was a pilot that we were working on in one of the metros in India. So you can see, more than addition to the face, we are able to also provide pose estimation of the user. And this was for an application that did a blacklisting of individuals. So the police department would have images of perpetrators, and whenever they come in through the station, we are able to detect them. And I think on the right hand side, we had some examples of a person who came through and we detected in real time. And you can see that there's a lot of detections going on here. So it's a crowded scene and it's doing pretty well. So this is our dashboard. So somebody had asked an example. So this is our DMS dashboard where we have, we provide a map interface. So that's actually, the app that runs on the phone and then sends data onto the dashboard. So these red points are basically where the driver was distracted when he was driving between point A to B. And you can actually click on those red dots and a video or an image will pop up and show you the actual event. And then of course we provide a score, and we can also provide top 5 drivers, and then we how many vehicles are being used, how many drivers are using the vehicles, and total hours of driven, total distance, and all those things. And then we can do, of course, speeding, harsh braking, all based on the sensors on the phone as well. So of course, this is just showing that we are cross-platform and we have a mobile app. And this is the video you just saw. So here Basically what we're doing is only when there is a motion and there is a person or a vehicle, we are able to send those images to the dashboard and provide the summary to the customer in form of like in a day, or how many vehicles were there, how many people were there, things like that. So we can actually customize, we can search through different times and all sorts of things. So it's a very easy to use dashboard. And then similarly we do have one for age and gender, basically for retail analytics as well. So how many people came to your store, what were they doing, and all those things.
How accurate is your age determination capability?
So right now it's about plus or minus 4 to 6 years, I would say. Anywhere between plus or minus. So basically, but it's more about, as I said, AI. When we deploy these solutions, with age and gender is almost 99% accurate, and age is about plus or minus, I think, let's say 5 years is what I would say.
Do you have a demo that you want to run on the audience here?
Well, I don't have an app right now. Yeah. So yeah, I mean, if you are interested, I can send an app. You can try it out.
But why was Ed asking? Why do you need age?
Why what? Why age?
Yeah.
Because he says that they're accurate, and I want to understand how accurate they are.
Well,
And if they're 20 years, that doesn't help. But if they're in a couple of years, or 4, 5, 6 years, then that helps you identify the gender and their age. It gives input to whoever needs this analysis.
Sales demographics, very people are always interested in those kind of
on the retail end,
Yes.
on the retail
right,
end,
yeah. So I mean, people be looking for that for years already, right?
Senior discount.
Yeah.
That's right. Yeah, that's
It won't be popular with women,
it. That's right. Yeah.
Right.
Yeah.
As long as it rounds down, we'll be okay.
Because men don't care how old they're, right?
And so you keep referring to your SDK. So is that product, or once I buy one unit from you, do I have access to that SDK? One of the restrictions.
Yes, so we do sell, we don't package everything in the SDK. So if your use case is, you just need, say, age and gender, for example, we can just provide you that app rather than giving you emotions and gaze, and which you actually don't need. So we can work with you and because each of those different IPs, they are almost an app by itself. So we don't want to be like clubbing everything and giving you something that you actually don't need. That's most of the companies. That's what they do. You have to buy everything, and most of the functionalities you don't even end up using. So here we can actually, if you need some features from the SDK, we can just repackage it and give it to you.
So, okay, so I believe that's all true statement what you said. My question was, do you purchase that as a separate product, or does it come as a part of, if I buy one of your hardware, software, one of your two products, does that person have access to the SDK?
Yes, if you buy our hardware, it comes standard with the hardware. So so the different levels of engagement that we have is, some people don't need the hardware, they already have their own hardware, so we just provide our software to them. If you need the hardware and the camera, we can provide you, and it comes standard in the hardware.
Thank you.
Yeah.
Did everybody hear the question and understand the answer? I know it's hard to hear in the back there, so be sure to repeat it.
Yeah, sure. I'll do that.
Yeah.
So his question was basically if with the SDK that we provide, does all the features come standard, and how to, if we have to buy the hardware, or his question was, does it come standard with the hardware? So answer is yes. So we do software IP licensing if you are just having your own hardware, but if you don't, we provide the hardware and the camera, and the SDK comes built in. So just wanted to go over this last slide where we are also selling our stuff in other markets as well. So we got a lot of interest from education institutions both in India, and in the US. So let me give you a little bit of a very nice example here. So when I was doing, when I was at MetHio, I was doing all their US PR stuff. I used to do a lot of demos, go to conferences. So in one of the conferences, there was this Chinese company called SenseTime, very next to us. So they were just a startup that were founded in 2014, and they were doing face detection on the cloud. And fast forward today, 2018, they are a 10 billion plus company. Just got 640 million funding from Alibaba. So, and they are the #1 AI company in the world, and they have access to about 17 million cameras in China, and their accuracy for age is plus or minus 1.
1 year?
Just 1 year. So they had this big screen in ISC West early this year in Las Vegas, and people were just walking in front, and the way it was detecting the face and the age, gender, it was like unbelievable at what accuracy that they can do. So that's exactly what trajectory we would like to follow, and in the strategic decision that we made to have an office in India is basically India is going to be the next China. So we have a lot of opportunities there in terms of AI being adopted today. So we have to wait and see how it goes. So anyway, so the other use case for us is in schools. We are also we are looking into monitoring student-teacher assessment for in a classroom. So today there is no way to quantify whether how your kid is doing in the school or how the teachers are doing in the classroom. So using analytics or different types of facial attributes, we can do that. And also there's a lot of issues today in schools about gun control and all those things, and arming more people with guns is not the solution. But if you monitor this person over a period of time, there's a lot of temporal information that you get that is very useful, like the facial or the pose or the way the student is interacting with other kids and all these things. All these features can actually be used to trigger something is going to happen in the next few days, so you better counsel this person. So there are a lot of, in AI gives you a lot of tools to be able to do predictive analytics in a very much more accurate way. And of course, security and AR, VR is basically everybody wants to do head pose estimations because you have wearing something on the head. And for robotics, there are a lot of retail and pet robotics security robotics that are coming into in the next couple of years. So we are working with some of the companies to do anything that has a camera and wants to get information about the world and get analytics. We can help them. And some of the companies that we are working with currently or talking to, this is a list of our market adoption. And of course, I just wanted to leave you with this thought here. So we just had a press coverage in both Dallas Innovates and Future Car about our technology. So basically our technology saves lives, keeps businesses and public places safer, and helps retailers provide the right shopping experience. So I think that's all I have, and I'll be glad to take any questions.
All right, so let's do a Q&A. This is a very interactive group. If we get them started, there'll be lots of good questions. So yeah, yes, come on.
Big question. Your AR VR SDK, is that considered a competing offering to AR Kit and AR Core, or does it integrate with it?
So I'm not working in AR anymore. So I am done. Yeah. So what that means is that AI solutions. So for example, the head pose and gaze for any of the head-mounted displays or what. So there's a company that we're working with that already has a camera on the Google Glass type of thing, where they're doing logistics and they want to get information. So we're able to solve some of their problems, and it's also used by police department to verification. So what I mean by AR VR is that we provide head pose and gaze, that can be integrated into the HoloLens and stuff like that.
You go here, go back here, say.
So my question might be a little bit one-off. Do you, with the camera and the sensoring information, how can you detect possibly like patterns and color hues versus, I guess, shape or facial recognition? More like an object. Carpet or material.
Like carpet or
Carpet,
material and things.
texture and yeah.
So yeah, the deep learning, the AI that we're talking about, so you can actually train the system to detect, so suppose you're interested in detecting a blue bag, you can train the system just to detect the blue bag. So I mean, you need a lot of images or videos, and you have to sit through and annotate. What I mean by that is, if you have images of a bunch of bags, you need to crop the region and provide do annotation. So it's a long process, but what we have done here is we have automated the entire data collection training process. So we are able to do that on the fly. So suppose we have deployed a solution and you want to now, we have detecting say 10 objects and you want to add an 11th object, it's very easy to do that.
You go back here because Melanie want to ask. Wait.
That's fine, no problem.
Raj, my question is twofold. One relating to the expressions, the additional quantity of expressions that your system detects compared to some of the others. Does that include body-related positions? For example, if you're driving, could you tell that the driver was resting their head on their hand or their arm? For example, like other body language-related signals of fatigue or being in the wrong place. And secondly, regardless of whether it's including body language type criteria or not, do the additional expressions that you're able to pick up, does that correlate to an improvement in system performance related to alerting about fatigue or a fatigue risk or a distracted driver sooner than any of the other systems? Like, is there a time efficiency and urgency value aspect that comes into the solution?
So I'll answer your question. There are different use cases there. So one is, if I understand you correctly, so you're saying if I'm resting my face on my hand, will I be able to detect that? So in addition to face monitoring, companies now are already looking into upper body tracking. So we are the video that I showed you of the metro station where we were doing the body joints. So we can do that for the upper body, just the upper body. So that gives you, a lot of information in addition to the face. Yeah, exactly. And then on the emotions, so when I showed you the Uber video, we are able to detect the crash almost 20 seconds before it actually happened. So, of course, the reason why I was telling you Tesla, even today, Elon Musk doesn't want to have this system because it will probably have him a lot more lawsuits than he actually fixing the problem. So the accuracy requirement is so high that, of course, the good part is if you solve that problem in the mobility space, you'll have such a good solution that can be deployed everywhere else. So that is what we are focusing on. So we are literally close to I would say 95 plus, and getting that last 3% is a ton of work, and we are trying to get there. Yeah.
Chuck here. You have a question?
Well, okay, so mine was a follow-on to Nick's question, and so you use the example of a blue handbag. So, can you give us a couple sentences of how you trained your system to recognize a blue handbag?
So what you need to do is you first have to go and collect millions of images of blue handbags or red handbags or handbags in general. and then somebody has to sit and draw a box around a bag that's in the scene. So suppose I have an image of this, I'm looking at this scene and I see a blue handbag somewhere there. I need to go and draw a square around it so that the machine understands it can take some features out of that blue handbag and can be used in training. So it's some numbers that it extracts from the blue handbag, and then it's trained, and it gives you a model. So when you deploy the model and now you have a new scene, so suppose you go outside and then you have deployed the model and then you can actually start detecting the blue handbag.
And that's how yours does it?
Yes. I mean, that's how general deep learning or AI works. So you need lots and lots of data and a lot of training and hand annotation. So if your annotations are really bad, then you will end up having, I mean, machine learning is literally garbage in, garbage out. So if you do a good job in annotation and data handling, your accuracies can surpass human intelligence. But of course, if you screw up in your, the way you do data annotations, you'll end up getting bad results.
Yashwant, real quick, and then we'll
Yes.
Steve, and then
I have a two-part question. You talked about facial identification and verification. Now, verification implies some kind of enrollment for people to get their faces enrolled in the system. And the second question is, I didn't see anything which actively engages the user in terms of any kind of speaker verification or any kind of speech recognition capability. All of this is very passive. The user doesn't have to interact with the system in any way. So is that coming down the pipe?
Yeah, great question. So what we are doing is there's a company that we are working with in New York. It's also a startup. So they are bringing emotion, like Alexa-based systems onto an embedded device. So the problem that they're facing is sometimes your voice-based emotions and your facial expressions don't match. So they want to understand facial emotions using our cameras-based system, and they want to tie up with their voice-based emotions so that in the end results can be actually attributed in the right way. So there are applications that, and also I think both of your questions. So today even car companies are looking into, so if you're going to test drive a car or you have a VR-based experience in all these showrooms, so they want to actually have a camera and look at how your experience is sitting in the cockpit of the car. So they want to understand, okay, turning this knob, how did you feel? So all those facial and emotions, so even the voice-based data that they're getting, they're using it to improve their system. So that's already happening.
Steve.
I was just curious if you've run across any use cases involving drones, not only in security and surveillance, but also I know a lot of land use, especially out in West Texas and South Texas and different areas where they're doing a lot of surveillance and other type of security. Have you run across any kind of use cases using the drone camera?
Drones, yes, I mean that's a upcoming field. So because our solution can work on really low power system that can be battery powered, there's no reason why it won't work. So we were looking into some agriculture based like detecting crops and stuff and all those things before, but that market is still not in a stage where you can actually go and monetize things. So, but our solution right now with what we are doing with object detection and people detection, it can easily be useful. Because the footage that I showed you, they're actually from a security camera where we're detecting vehicles. But now if you're flying a drone, it will be a little more a top view. But doesn't matter. The AI system it handles all the pose variations, and doesn't matter where the camera is. It handles all those issues very well.
Craig?
Make it walk all the way back. So, I mean, you're collecting a ton of data and you are analyzing a lot of images. a very realistic question is going to be, how do you manage privacy concerns? Because you are collecting a ton of data, not necessarily with people's approval or consent, and you're storing that data. So how do you manage privacy concerns? Because this is going to be the next big challenge in tech. Is we are invading, our industry is literally invading people's lives without their consent. So how do you manage that?
So I'll answer that question in two-fold. So one is we don't work, currently we're not working totally with the end customers. So we do partnership with businesses that already need some of the solutions. So they are interacting with the customers and they are taking the liability of data collection, and they are providing signs saying that you're on active surveillance and stuff like that. So there's already some information being provided to the end user that this data is being used for customer analytics or whatever that use case is. Now coming back to where we are processing the data, as I was telling before, when we store the data on the cloud from our system, we don't store any images. So the images that I showed you on the dashboard, they are when the customer says, yeah, we need this, then they have an option to enable that capability. But in general, we don't save any images, and even even for recognition, whatever the tag that we provide is some ID, it's some 12-digit ID. There is no name or anything being disclosed of the user. Plus, the face is not even uploaded. It's a bunch of numbers that is associated with that particular ID. So you cannot go back and download the features and reconstruct the face. You cannot. It's impossible to do that. So that way we are a privacy preserving technology. So we don't want to get into that also.
Oscar? Rather simple question, but the drone example, the drone use case kind of made me think about this. Like, what are your distance parameters? In other words, like, from what distance can you detect with accuracy? Can you give me a little bit about those parameters?
That depends on two things. One is your camera resolution. So if you give me a 4K by 4K image, which usually happens on the drones, the processing, if I want to run that on this phone, I have some limitations because it's the capability, not the capability of the AI algorithm, but I need to tell it what is the minimum size object it has to look for. So right now what we're doing is it's about 200 by 200 pixels. If I go to 20 by 20, it's a 10x decrease, and I have to process such a minute region in the image. So that will add a compute cost to my current thing. So I can, if I have a 2x compute capabilities, I can do that. So distance doesn't matter actually. So it's all about telling the AI, so what's the smallest size image object that you want to look for, and the compute power. Because if you think about it, like sliding a window of 20 by 20 over a 4K by 4K image versus sliding a 200 by 200, you'll see how much of a cost difference that is.
Oops. Sorry, Ari.
So what happens if you have an image? If I show your camera a picture, if I show your camera a phone with a video of a person, will it try to detect all the features, the gaze and everything in the video, or will it be able to tell that this is a foreign, this is not really in the scene?
So you want to detect fake versus real person?
Someone who's present versus someone who is remotely present.
Right. Today we don't have that capability. I mean, it just scans the, if I show like a phone image and my image side by side, it will do on both.
Okay, last question, and then Rajesh will be glad to stay late. We have the room till 10:30. So, anybody else have another question?
Do you have or do you plan to have any APIs as part of the SDK, or what's your plan vision for that to integrate with other solutions?
So as I was mentioning, I mean, we have these solutions that are, we don't package it into an SDK. So if say your use case is, you just need 2 of those features, we can compile that in an app, or we can provide you that box and only charge for that application, that IP. So because our entire SDK, because I was telling you, each of these features are a different network, so you need to load them into the firmware and all those things. So we make sure that whatever you need, we provide you, rather than we giving you an entire SDK of which you probably don't even use some of the features. Yeah.
Very good. That'll be our last question. So